Uh, Let us start this fifth session of the second module. Now, actually, in the fourth session, we have discussed one of the type of turbines, that is a Pelton turbine or a Pelton wheel turbine, which comes under the category of the impulse turbine, where we have seen how this impulse turbine also comes to be in the category of high head turbine, where the head of the water will be more than 300 meters. That is what which is been used in Sharavati. Now in this session, let us talk about the other type of the turbine, that is the reaction turbines. We have got even in the reaction turbine we have got low head and medium head. The table of contents follows reaction turbines, water reaction turbines, and then we will study two types of reaction turbines: Francis turbine and Kaplan turbine, and the difference between impulse water turbine and reaction water turbine also. Okay. Now, because whatever that impulse turbines, in the impulse turbine category we have discussed the Pelton turbine. In the reaction turbine category we are going to discuss the two more turbines. Then we shall differentiate or find out the differences between impulse turbine and reaction turbine. Basically, one small note I just want to make out here. In the impulse turbine, the force of action, that is impulsive force of action, is major cause for conversion of kinetic energy into the mechanical energy. Whereas in the reaction turbine, what happens? The reactive force of action plus impulsive force of action, that is the pressure energy and kinetic energy, both the impulsive force of action and the reactive force of action. That means the pressure energy and kinetic energy of the water jet makes the uh, water energy to convert into mechanical energy. Is it clear? Now, reaction turbines are acted on by water, which changes pressure as it moves through the turbine and gives up its energy. They must be encased to contain the water pressure or a suction, or they must be fully submerged in the water flow. Okay, this is the one difference what we can make it out in the impulse as well as the reaction turbine, where the impulse turbines need not to necessary to submerge it. Okay, Newton's third law describes the transfer of energy by reaction for turbines. That is what I was just talking even in the previous session. If you take a balloon and release that mouth, so what happens? The water, the air with higher pressure will tries to escape out in this direction, and the balloon will tries to escape out in this direction. So the air will move in this direction, and the balloon will tries to move in this direction. So they are opposite in direction, but the air, if it goes like this, and the balloon if it goes like this is because of the reactive force of action. This is in the reactive force of action, whereas this is a normal action. So according to Newton's third law, it just works. Okay. Now most water turbines in use are reaction turbine. It is only because the major advantage of being a reaction turbine, it is these reaction turbines can also produce electricity at low head. No, we cannot expect the rain to be same for all the 365 days or all the years. We cannot expect the same amount of rain. Obviously, the water level may vary. One small common sense: if you want to have a Pelton turbine, you should have a 300 meters of height of water. Whereas for a reaction turbine, how much we require? 50 to 150 meters. And if you take a Kaplan turbine, it works even below 50 meters. Even below 50 meters, it can work. 50 meters of water and 300 meters of water, which does requires more energy? Obviously the 50 meters are below 150 meters. So that is the reason why most of the occasions they go for the reaction turbines. That is a major advantage. They are used in, that is what the point I have given it in the one, they are used in low and medium head applications. Francis turbine is one of the beautiful turbine which is stands an example for the reaction turbines. Now what happens even in this reaction turbine, the Francis turbine? This Francis turbine is a mixed flow. That means it enters the it enters to the casing of the turbine radially and leaves axially. Are you getting my point? It enters radially and leaves axially. So this is called as a radial flow and it leaves axially. It can be inward or it can be outward, but it enters radially and leaves axially. So this is what a mixed reaction flow turbines for a medium head. Medium head comes under the category of what? 50 meters to 150 meters. It falls between 50 meters to 150 meters. Low head means less than 50 meters. Okay. It was the first hydraulic turbine with a radial flow designed by American scientist James Francis. James Francis is a person who, American scientist who invented this hydraulic turbine initially. The figure shows in the next slide, I just shall show you the top and front views of the Francis turbine. The different parts of the turbines comes under the runner. First one is the runner. A runner is a circular wheel on which a series of curved blades are being fixed, as in case of impulse turbine also. But the in the impulse turbine we will have a buckets or a cups, whereas here we have got a blades. Blades, it is a lot of difference, my dear friends. Buckets are something like this, like a cups, whereas the blades are something like this. Is it clear? So this curved blades are being fixed to the rotor, between the rotor. The number of blades usually varies from 16 to 24. The minimum of 16 number of blades to the 24 number of blades have been fixed to the runner. The runner in turn is coupled to a rotating vertical shaft. This is the one, actually this is the front view, and the below one will show you the top view of the top view of the turbines. Now you can see this in the front view. We have got a runner which has been shown over there, and there are two spiral casing on both the sides. This is a volute, what we call it as a volute. If you go for any waterlands, you will always have a closed tubes which will be spherical in shape. So this is called what we call it as a volute. This is how it just makes the water to flow. Intentionally they will make it into flow, so that what happens, its pressure energy keeps converting it into the kinetic energy of the blades. Okay, the water while moving in the spiral, so what happens, the pressure energy of the water will be converted into the kinetic energy of the water. These are all called as a guide blades. Guide blade means whatever the water which is coming through the volute will be guided. Instead of a nozzle, we will have a guide vanes, or what we call it as a guide vanes or guide blades, which guides. It is something like a passage which shows in which direction it has to flow, and that is what we call it as the guide blades. Then we will also have a shaft at the middle, which uh, being coupled to a runner. Now as you can see this, the spiral casings on both the sides, we will have a plus mark. So these two are called as a spiral casing or a volute. On one side it is larger diameter, and the one side it is smaller diameter. It is only because, my dear friend, the diameter keeps decreasing through the volute. It enters with a higher diameter pipe, and as it passes through spherically, the diameter keeps reducing. So that is what we call it as a spiral casing or a volute. Now this is a draft tube. Now here, my dear friends, what happens, since it is coming radially, this is coming radially after striking the blades. After striking the blades and generating the mechanical energy, it falls down axially. It falls down axially. Now one small example, the water which is falling from the second floor of water through a pipe, if you keep something at the bottom, it will corrode the floor itself. It will destroy the floor itself. Then you just imagine so much of amount of water which is coming out axially outside. So what happens? It will damage the floor itself. So what we will do it is, it will be coming with a very high velocity. So if you can see this draft tube, please observe it here carefully. The draft tube, it is increasing in the section. It is increasing. It is something I can show it like this. It is less over here and it is more over here. Is that clear? Now this is less and this is more. The area available here is less and the area available here is more. That means diverging sections. Diverging section are increasing in the area. Now what do you remember in the nozzle? There is a decreasing in section. How was the nozzle? Nozzle was like this. Increased area over here and decreased. Is it clear? So there the pressure energy is converted into kinetic energy. Now here what happens, because the draft tubes are like this, what happens? The kinetic energy is been converted into the pressure energy, so that the velocity with which it coming with faster will be decreased, the velocity will be reduced, and then it will be given to the time rise. That is the beauty of this draft tube. Draft tube plays a vital role. This draft tube was there in the impulse turbine? No. Draft tube wasn't there in the impulse turbine, only the tail race was there. Now here the draft tube is there in order to reduce the velocity of the outcoming water from the turbine blades. Is that clear? Now if you see this top view, the water which is flowing over here. Now please be careful. Now please observe it here, the arrow marks. The arrow marks where the water is entering here, you can see the area is more. As it come across us with a spiral casing. Now here you can see this. These are all the guide vanes in which the water will flow here like this. Guide vanes are just like a guide vanes in which the water will be made to impinge directly onto this. Now guide vanes function is same as a nozzles, but we don't have a nozzles here. That's it. Instead of nozzles, we are using a guide vanes. Now these guide vanes at the entry, the area is more, and at the exit, which will guide to the moving blades. These guide vanes are fixed. Guide vanes are fixed. They will not move. Only the inside one, inside moving blades or a runner blades will rotate. The water will enter over here, and as you can see this, the arrow marks, the water along the spiral casing, as it is getting progress, the area is being kept decreasing. As the area is kept decreasing, its pressure energy will be converted into kinetic energy. Makes this to enter it inside this and makes this to rotate faster and faster. As this runner blades rotates faster, the shaft also rotates faster. Is that clear? So whereas the moving blades are free to move, whereas the guide vanes are fixed in motion. Is it clear? So this is the difference. Though this sets up very high velocity, and then Francis turbines have got a higher capacity of producing electricity. The efficiency of Francis turbines is much higher than the other type of turbines. That is one of the reason why people go for the Francis turbines compared to the rest of the turbines. Okay. Now let us see. This is called as a guide wheels or the guide vane. See, these are all called as a guide vanes. The guide wheel is also a stationary one, fixed. Guide vanes are fixed to the guide wheel. Is a stationary wheel around the runner. Okay, around the runner it is being used, and then it makes the runner of the turbines. A number of blades are fixed around the circumference of the guide wheel, which are called as guide vanes or guide blades or stationary blades. The guide blades allow the water to strike at a certain angle onto the moving blades. It is just a guide vanes or guide blades function is to allow the water to strike the blades at a certain velocity and certain angle. That's it. So that the energy will not get wasted. The blades are designed. The blades are designed. The guide vanes allow the water to strike at a certain angle on the moving blades. The blades are designed in such a manner that the water, while flowing through the blades, will be subjected to nozzle effect. In other words, the pressure energy of the water will be converted into kinetic energy during its flow over the blades. Spiral casing. Spiral casing is also called as a scroll casing. Scroll casing, not casting actually, mistake. It's a scroll casing, or we also call it as a volute. Spiral, it's because it is in the spiral casing, or it may be a scroll, it just crawls out, or it is a volute shape. The spiral casing is a closed passage surrounding the guide blades, as shown in that previous figure number B. The cross-sectional area of the spiral casing gradually decreases along the flow direction in order to distribute water uniformly around the entire perimeter of the runner. Now, as it is, you just observe it here. Now, the area which is available, the flow of water, the arrow marks, it is entering with certain area. As it progresses, you can see this area is decreasing. That is the reason why in the top view, in the front view, what you can see it here, the diameter on the left side of the volute is higher diameter. On the right side, we have got a lower diameter volute. So that means the area is keeps decreasing. Is it clear? So it is something like this. It is completely a circular one. Since it is a front view, it appears to be like that. Okay. Now the spiral casing is also known as a scroll casing or a volute. Draft tube is one of the important factor in the reaction turbines. The draft tube is a tube or a pipe of gradually increasing area used for discharging the wastewater or after striking the blades water. So what happens from the exit of the turbine to the tail race at the low pressures? It does not allow the water to fall freely to the tail race as in case of a Pelton turbine. Pelton turbine, and what happens? It almost loses its energy and it falls down very freely. Whereas here it will have still the energy. So that high energy with which if it is been allowed to fall down, it will damage the floor itself. So that is the reason why they will go with the draft tubes with diverging sections, with increasing area. Working of this, in operation, water from the reservoir flows through the penstock and enters the spiral casing. As the water flows through the tapered spiral casing, a part of its potential energy is converted into kinetic energy. This is what I have been telling. Once it has been entering, because of the converging section, because of the volute, what is happening, a partial amount of potential energy will be converted into kinetic energy. Water flows through the guide blades, gets deflected, and then flows radially inwards. So it is radially inward flow to the outer periphery of the runner. The water then moves over the moving blades in a radial direction. It is finally discharged to the tail race axially from the center of the runner via a draft tube. During its flow over the runner blade, the blade passages act as a nozzle and the remaining part of the potential energy is being converted into the kinetic energy. It is important to note at this point that the jet of water does not impinge on the runner. In fact, they are leaving the runner at a very high velocity. So the momentum is converted into force, force as in case of impulse turbine. Since the water leaves the blades at a very high velocity, there is a reaction force of on the runners. So that means we are getting the energy both by impulsive force of action as well as the reactive force of action. By both the methods, we are going to find out. Uh, we are going to harness the energy which is there in the water to the mechanical energy. Okay, since the water leaves the blades at a high velocity, there is a reactive force of action. That means if you check this, if it is a cup like this, the water which comes out here like this, it impinges. That is impulsive force of action. While living, it just leaves like this. It just leaves like this. It just leaves like this. So while it is living, there will be a reactive force of action. Now this is an impulse force and this is a reactive force. So both impulsive force of action and reactive force of action together results in mechanical energy generation. This force sets the runner into rotary motion. Hence, the shaft connected to the runner also rotates, thereby going for a useful work. The shaft in turn drives the generator to produce electricity. Advantages and the disadvantages. Now, no head loss occurs even at low discharge of water. So the maximum head is being used in this reaction turbine. Disadvantages: eddy losses are more. Eddy losses means when it goes with the spiral one, the eddy flow will be taken place. That eddy losses will be more in case of reaction turbine. Since the spiral casing is grounded, runner is not easily accessible. Hence, dismantling is difficult. The following are some of the reactions turbines located in India where Francis turbine is being installed. Actually, Shivana Samudra, I'm so sorry. Actually, in Sharavati we have the impulse turbine, and even in the Shivana Samudra we have the reaction turbine. Okay, in Bakra Nangal, Punjab, we have got a reaction turbine. This is actually Shivana Samudra is also called as a Shimsha Shivana Samudra, and then the Gandhinagar in Rajasthan will also have is also having a reaction. There is a Francis turbine. Rihand, that is one UP in Uttar Pradesh. We have got the Francis turbine. The other type of a reaction turbine is the Kaplan turbine. The Kaplan turbine is a low head reaction turbine which works even under 50 meters. Is it clear? So flows axially. Figure shows the rotor and the front view of the Kaplan turbine. Kaplan turbine consists of the following parts. One is the guideways and then the runner blades, and then we will also have a few of the shaft, the spiral casing, and then the tail race hub also we will have it along with the blades. Working of Kaplan turbine, basically I just shall show you the sketch over here. This is what okay. This Kaplan turbine are also called as a propeller turbine basically. Why? Because this resembles the propeller shaft of a ship. The nature of propeller shaft of the ship, this is quite similar one. That is the reason why this is also called as a propeller shaft turbine. Kaplan turbine is an axial flow reaction turbine and is used where large quantity of water is available at low head, more amount at a lower head, that is less than 50 meters head is available. Then we will go for the Kaplan turbines. The turbine consists of a hub or a boss. This is called as a hub or a boss, the bigger one, hub or a boss. So what happens? For a vertical shaft bosses, it has been fixed. The runner blades attached to the hub are adjustable and can be turned about their axis to take care of change of load. The runner has only 4 to 8 blades, whereas in a Francis turbine we have got around 16 to 24. Is it clear? So similar to Francis turbine, Kaplan turbine also has a ring of fixed guide blades at the inlet to the turbine, and the inlet is a scroll shaped tube surrounding to the fixed blades. It's a similar one as you can see it here. The scroll casing or a spiral casing, or we also call it as a volute. The water which will be entering into this volute will be with a higher area. As it keeps progressing, it is also a axial flow. It is not a radial, it is an axial flow. What happens? The area decreases, which leads to the water which falls onto this turbines is an axial one, not radially directed. It is an axial one. See, something like this. The turbine blades are like this, and the water will be falling from top to like this. When it comes and it reaches here, it makes it to rotate. So it exactly in the opposite principle of uh, ship propeller. So this comes under the category. This is also called as a propeller turbine. Please be careful. Now we will have a vertical shaft. For this vertical shaft, we will have a hub or a boss. Hub or a boss is entirely different than the centermost portion of the runner blades. We will have a runner, right, in the Francis turbine, or it may be even in the impulse turbine. The runner is a disc-like wheel, whereas here it is a big diameter hub or the boss. What happens here? We will also have a guide vents as in case of Francis turbine. The water comes over here, and these blades, now as in the figure number B, what you can see it is here the blades. These blades will be fixed here like this, and these blades can be tilted be, depending upon the load variations. This is how it will be. This is how it will be. We can vary this directions, as that is what we can see it here. Is that clear? So that is the beauty. Now after striking the blades, so what happens? The water will flows into the tile race and it will be taken out. And even here also it is a draft tube. It will be an enlarging or diverging section that will be placed. That is being placed over. In operation, water from the reservoir flows through the penstock and enters into the spiral casing. A part of potential energy of the water will be converted into kinetic energy as usual, even in the Francis turbine also. The water then moves the glide blades, fixed blades, and gets deflected and then flows axially. There is only difference. In Francis turbine, it enters radially. Now here it enters, flows axially through the runner blades as shown in the figure. During its flow over the runner blades, the blade passages acts as the nozzle, and remaining part of the potential energy is being converted into kinetic energy. The water leaves the runner blades at a very high velocity as and as a result a reaction force is being set up by causing the runners to rotate at a high speed. Hence the shaft connected to the runner also rotates, thereby doing a useful work. The shaft in turn drives the generator to produce electricity. That is the one thing. Now let us go for this major difference between impulse turbine and the reaction turbine. We have already discussed the principle of working. In the reaction water turbine, the reaction turbines are used for low and medium head. Okay, whereas this impulse turbine only for the high head. That means when there is a scarcity of head or water is not there, then the impulse turbines cannot be used. So this impulse turbine works only with a very high head of 300 meters. I'm not talking about the quantity of water, I'm talking only the head of the water, where this impulse turbine will work under 300 meters of head, whereas here the reaction turbines works under a head of between less than 50 meters, that is for the Kaplan turbine, and for the Francis turbines works between 50 meters to 150 meters. Basically, then the pressure drop occurs in both fixed and moving blades. Pressure drop of the water occurs both in fixed blades as well as in the moving blades, but whereas this no pressure change occurs at the turbine blades, only the pressure change occurs at the nozzle tip. That's it. No pressure, no question of pressure change even in the turbine blades. Now one more point we will have a blades in the reaction water turbine, whereas in the impulse turbine we will have a buckets or a cups. The shape of the cups is different than the shape of the blades over here in the Francis or the reaction turbines. Part of the pressure energy is converted into kinetic energy in the spiral casing, and the remaining in the blade passage that acts as a nozzle. Okay, pressure energy is completely converts into kinetic energy in the nozzle itself. That is why there is no question of conversion of pressure energy into the other form of energy later on stages. Reaction turbines rotate faster given the same head and flow conditions, and here it is comparatively low. Reaction turbines require more sophisticated fabrication because of the use of large and more intricately profiled blades and casings, whereas here the comparatively easy in fabrication, and only thing is the blades has to be symmetrical, that's it, so that the maximum work has been extracted. Reaction turbines must be encased to contain the water pressure or suction, or they must be fully submerged in water flow, whereas this is relatively not necessary at all. And one more difference what I would like to tell you, in reaction turbine tail race or draft tubes is mandatory because of reducing the pressure energy, whereas impulse turbine doesn't require any draft tubes. That is one of the major advantage. Now we can increase the points, but major have been given over here. It is a mixed flow turbine, whereas it is an when it I'm so sorry. This is the difference between Francis and a Kaplan turbine. Francis is a mixed flow turbine, whereas Kaplan is an axial flow turbine. It's a medium head and this is a low head, and it has got number of blades of 16 to 24, whereas this is maximum 4 to 8, not 3 to 8. It may be 4 to 8. The runner is supported by a driving shaft. The runner is the extension of the vertical shaft. There is no runner over here. Okay. Guide vanes are assembled with the help of links and levers to act as a valves, whereas here it is adjustable smooth flow water. Requires a large space and requires low space. Eddy losses will be there in the Francis turbine. No eddy losses because it is an axial flow. Okay. Cavitation do not occur, whereas here the cavitation are likely to occur. Draft tube is simple elbow shape, and this is a rectangular shape. That is what we have discussed. And these are the few assignment questions.